business world. I mean, the main thing that business people do is we make decisions. That's our job. And the more times we're right, the better off we'll be. So an ad hoc query, what's that mean? Well, we're asking the database a question based on a problem we have. And let's convert that. Now let's talk about 1950, before most major companies had computers. If you said, gosh, I think the bulk of our customers are male, left-handed, red-haired, and over 35 years old. You look at the young, brand new graduate from the University of Idaho and you say, go find out for me. In 1950, how would you find out? If they recorded that data on paper somewhere, you'd be down in the bowels of the company going through the paper files and taking notes and scribbling things down, and then you're running an ad. You know, it would take you weeks to figure that out. And you come back and you said, boss, I don't see it. They don't seem to, oh. Well, maybe I meant right-handed. Go figure that one out. It doesn't take very many of those kind of ad hoc queries before you said, I need another line of work. Okay? Whereas with an ad hoc query, I can type it into the database. I can run an SQL query, and I go, not that one. That looks better. So I can manipulate the data. I can do more examination of the data in a much less formal environment, much lower cost. And we can actually build user views, right? One of the big problems with the database system is not having enough data, but having too much. Like taking a drink out of a fire hose. So you can have a user view, a report that an individual user wants to see. You may not want to see the sales report every day. You might want to see it every week. So you can set that up so it happens for you. And maybe you only want to see the sales report. You don't want to know about the salesman. So you set that specifically for that aspect. So there are lots of advantages with databases. But in the immortal words of the philosophers, there ain't no such thing as a free lunch, right? You pay for these performance enhancements. One of the biggest problems is high upfront cost associated with data modeling. And right, you think about this. You want to design one database to handle all the problems that the company has. There's a significant amount of planning that goes into that. You can't just fix little problems. You have to come up with a complete solution. So the amount of planning is non-trivial, right? And it's very costly. Slower systems response occurs because you're going from your application, it used to be you go from your application to your data, very short pipeline. Here you have to go to a database engine. And depending on how many other people are asking the same kind of questions, could it really impact your speed? Like maybe you're doing end-of-the-month reports when everybody else is doing end-of-the-month reports, right? And security issues increase. And people go, well, how do security issues increase here? Well, number one, you have a whole bunch more data there. The more data there is, the more valuable it is, the more likely it is to get stolen. Databases are designed so you don't have the one programmer problem, the programmer from hell. So it's written in clear English, right? It's easier to understand it. So databases are easier to interpret, so you can get that information out quickly. So databases become a security problem. They become a target because they're valuable. Now you can, there are things you can do to make that better. You can encrypt the data, you can protect your database, but those slow down your system's response even more. So there's a disadvantage there. And finally, there's just data maintenance. If you got a whole bunch of data in there, you got to maintain it to keep it current. You got to, when people move, when things change, jobs change, pay rates change, you've got to keep after it. And the more data you have, the more you have to spend on maintaining and keeping it current. So these are database limitations. So, where is it? I had a cartoon. Oh well, we don't need a cartoon. So there's some terms, some language that we use when we're talking about databases that will make sense. Will help what I'm saying make sense. The first is an entity. An entity is an object of interest about which data is collected. Students would be entities. And, professors, instructors would be entities. Whatever, products would be an entity. A customer would be an entity. What do we want to track information about? Now, an attribute is a characteristic of interest about, about the entity, right? About which data is collected. Okay? If we have a customer, maybe we have the customer name. Maybe we have their address. These are all attributes. Maybe we have their income level. Maybe we have information about the fact that they like chocolate, right? Whatever it is. And so we have an entity, which is a thing we're interested in keeping data about. We have an attribute, which is a characteristic of interest. And then we have an instance, or if you want to impress people with your language, we have an instantiation of an entity. So we have students at the University of Idaho. So an instance or an instantiation would be Mark Rounds, and then the other information all about me, right? So an instance of an entity is an actual example of it, an actual thing. Then we have two kinds of keys, and I will tell you right up front that this is the part, these two keys, the primary key and the foreign key, that will cause the most problem discussing databases, right? So, if I had pom-poms, I would wave them now. I would say, pay attention to this part, okay? A primary key is a unique identifier. Every record has to have a primary key that makes sure that that record is unique, okay? For example, University of Idaho, you have a primary key. It's your student ID number. There's no other student that has your ID number. If you are in America, you have a social security number. No one has your social security number. It is unique to you, right? Now, in order to make databases efficient, we can use that primary key somewhere else, right? We define a link between tables. Let's say we've got customer, Mark Rounds, customer, right? Now, we could set it up so that that one record also had every transaction, but you'd have to have, let's say it's the coffee shop here on campus, you'd have to have 5,000 entries, right? I get a cup of coffee like 4 times a week. So instead, what we do is we build a separate table that's, coffee sales, right? And they put that in there, and then they take my primary key, my customer ID, and they put it on that record. That way they don't have to recreate all the data in the primary key. They just have, my customer number, which is 452-789 or whatever it is, and they have access to all that. They can make the connection. This is what makes databases powerful. Primary key to foreign key. We're going to hit this several times because you get this, you'll get databases. You don't get this, it'll always be kind of magic, and we don't want magic, right? All right. Just quickly, graphically describing this, right? An entity, right? We're talking about suppliers or parts or customers, right? This is stuff we want to collect data about. Attributes, characteristic of interest, which data is collected. Name, what have you. Instance, which would be an occurrence, right? And a unique identifier, which is your primary key. We have an entity. We're talking about suppliers. We have attributes, name, supplier code, address. Then we have our attribute values. ABC parts. The supplier code is 4593 in Seattle, Washington, right? We have our unique identifier. We could make it name. I throw this out here because I want to talk to you just a little bit about using name as your primary key. It's not a very good idea. Have you ever Googled yourself? I've done that just to see what was out there, and I found some pretty interesting guys with my name. There's an oncologist, a guy who's a cancer doctor. There's a researcher in eye, how your eye actually takes in vision and that kind of stuff, which is kind of cool. There is a jazz bass player, and I actually listen to him on YouTube. He's pretty good. And in Ohio, there's a child molester with my name, okay? Now, because I teach at a university, I really, really don't want the records between the child molester and Mark, the college instructor, to get crossed up in any way, shape, or form, right? So using a name is a bad idea. That's why they go to numbers, all right? And these constitute the instance or the instantiation, the occurrence of that entity. Does that make sense? Okay. Another example of the same thing using multiple tables. We have an order table, a part table, and a supplier table, right? Now, each of these rows is a record, or if you want to impress people that you understand database words, you can say tuple. I always thought that was an awkward word, but that's what they use. Anyway, we have this order. So we have an order number, primary key, right? Then we have order date, delivery date. These are items, right? And we have this part number. This is a foreign key. You look at that part number, 152. Oh, that's compressors. You don't have to put in all the data about compressors. You just have to put in that foreign key. We've got this compressor thing. So then we're looking over, okay, we got the name, we've got the price, we got the supplier number. So now we know where to order them just with one number. See how that foreign key thing makes a chain of information so that, gosh, I've got this order and I sold part number 152. What's a 152? Oh, it's a compressor. Where do they make those? That's Bryant Corp in Rochester, New York. That chain, okay? That allows you to enter in the data only one time. Because let's say you had 8 people that came in and bought compressors. And if you didn't have it this way, you'd have to write in, well, they bought a compressor and it was $70 and we got to order them from Bryant. So you're going to mess it up. At some point, the biggest cause of errors in computers are people, right? I used to do this exercise with one person in class. It's kind of silly, where I would put $10 right there, $10 bill. And I said, all right, everybody has to write your name perfectly 100 times. And the first person done gets the money. Right? So people start writing their name because they're going, $10. I could use $10. Coffee, maybe go out with my girlfriend. Their mind wanders. Oh, you screw up your own name. Happens every time, right? So this is how the system works, right? Primary key to foreign key. We're going to hit this again, but this is important. So, what's a relational database? It consists of tables, right? And these links are maintained with primary and foreign key links. The advantages of relational databases. We have less data redundancy, right? Instead of putting, I've been going to college most of my life. I've taken a gazillion college courses. And I will guarantee you that in all those locations, they don't have Mark Rounds, lives in Great Falls, Montana. Oh, now he lives in North Dakota. Nope, wait, he's moved. They don't do that. They have Mark Rounds, one record about Mark Rounds, and they took database, took business law, took anthropology, There's less that you're not repeating the data as much, so it's easier to enter and easier to keep track of. It's easier to conceptualize, and you design your data based on the entities, the data you're trying to keep track of, not designing based on your application's program. Because while it'll run faster, you're going to tie yourself to a specific group of programmers. There is the cartoon I wanted. All right. I just got the consultant's report. He has identified our biggest problem, Wally. I recommend we build a tracking database. We can put it on the network. Would you like to hear what the problem is first? Oh, I hate to dwell on the negative. We like databases. You haven't heard what the problem is yet. How can you recommend building a database to solve it? We always build a database, and we'll need coffee mugs for the project team. The problem is we have poor processes. That could be the slogan on the mugs. What this cartoon brings to mind is something my dad taught me a long time ago. When, you know, and the saying goes like this: when your only tool is a hammer, all your problems look like nails. Databases are tremendously powerful. Unfortunately, a lot of people use them for dumb things. So choose wisely how you use your tools, because there are a lot of different tools out there you can use. All right, that covers all the fun I want to have today. Let's quickly run down the assignments, right? Chapter 2, read, do the quiz, all right? Get the textbook. First milestone for the mini project, come up with an e-commerce idea. It's a little company. You can sell sock puppets, I don't care. And then there was a quiz. There was that. What was the third one? I said. Yes, thank you. The 1 hour programming. Start that. That's not going to be due until the end of the